So this right here is same base. I'm going to add my exponent. So x to the a plus b. This is called the multiplication rule. The thing about the ACT is they love exponent rules and they love to give you incorrect answer choices that reflect the common mistakes that you make. So I want to make sure we don't make silly mistakes. So the best reminder for the multiplication rule, you have to have the same base, meaning these are both x's. The same bases, they have to be multiplied together. So same bases multiplied together. What you're going to do is add the exponents. Okay? So same base, you have to match the same bases together. You can't just add everything you want to. So same bases, add them together if they're being multiplied. Oh, I haven't shared your presentation, have I? Thank you. Hold on. There's lots of things I need to remember. There we go. Let's see. Is that working? Is that better? Okay. Thank you. All right, so let's do the first example. X to the 3 times x to the 4. What is that? X to the 7. All you do is add 3 plus 4 is 7. What about the next example? Okay, y to the 5, because 3 plus 2 is 5, and then x to the 8. You have to remember that even though there's no exponent shown, it's understood to be a 1. So what that means for the ACT is they are purposefully going to put the answer y to the 5, x to the 7, because they want you to forget to add 1, and chances are they'll put it first because you like to see incorrect answers first. You get excited when your answer is first for some reason, and they know that. So make sure you're adding the 1 here. You can also flip it. So if the answer has x to the 8 first and you wrote it second, it's the same thing. You're allowed to flip-flop them. So don't get discouraged if you wrote your answer in a different order. It's going to be the same. You can always flip-flop. All right, what about the division rule? X over A over B, or x to the B. Subtract. Which one do you subtract? Top minus bottom, as long as everything is positive. So in this case, we subtract. So this becomes x to the A minus B. So some things you have to know. You have to know negative exponents, which we will review real quick. But whenever you have subtraction with division, you want to look for negative exponents. So look for negative exponents to move. So if you've forgotten negative exponents, we will go over those. If they're negative, it just means they're unhappy with where they're located, so you have to move them to make them positive and happy. So look for negative exponents to move. And always subtract the large from the small. So always subtract large exponent from small exponent. I guess not the word from, large minus small. That's better. So you always subtract large minus small. Big exponent minus small exponent. If you don't, okay, you're going to end up with the exponent in the wrong location. So you want to make sure everything is positive. So you can't do anything until you have all positive exponents. Then you subtract the large exponent minus the small exponent, which means your values could be in the numerator or they can move to the bottom. Again, you want to make sure that you match the bases. So x's go with x's, y's to y's, r to r. Always make sure that the bases are the same. So look for negative exponents to move and always subtract large exponent minus small exponent. All right, so what about the first example? We got x to the 5 over x to the 3. x to the second. So the large is up here, so I can subtract 5 minus 3 for x squared. Make sure that you're subtracting large minus small so you don't get negative exponents. Okay. What about the next example? The one to the right. X to the 3 over x to the 5. X to the negative 2. So when I get x to the negative 2, how can I rewrite that with a positive 2? 1 over x to the 2. Good job. 1 over x to the 2. So things you want to remember, if you have a negative exponent, but there's no fraction to be shown, you can always put 1 underneath the x to kind of visualize the fraction. So right here, I can put a 1 right here. And then I can go ahead and move the x to the bottom. Just be mindful that if I move everything to the denominator of the fraction, that there's a 1 left up top. You're not going to put 0. You have to put 1 because fractions go with multiplying. And if I multiply by 0, I get nothing. What about the last example? Yeah, x squared is on top. So what I'm going to do is match. I have x cubed and x to the 1. The exponent for x is larger in the top, which means x will stay there. So 3 minus 1 is 2. And then looking at the y's, they're both positive. So I see the larger is in the bottom, which means y will stay in the bottom. 7 minus 2 is 5. Okay. It's okay to cancel things out. If they cancel or simplify, just be mindful that you're matching the bases. X's go with x, y with y, and so on. Feeling good with division? Okay. Power to a power is the one that you confuse with the multiplication rule, which is the first one we learned where we add. A lot of the times what happens is you want to add them together. You kind of interchange the first two rules. So what happens when I have x to the a to the b? What should I do with my exponents there? Multiply them. Yes, multiply. So this becomes x to the a times b. Multiply. So whenever you have a power raised to a power, you multiply. Power to a power, you multiply the exponents. I know it's a lot of rules, and the ACT will purposely give you the incorrect answers using the wrong rules because they expect it. All right, what's the first example? X to the 3 to the 5. X to the 15. Good job. I just multiplied. What about the second example? X to the 24. So 3 times 4 is 12. 12 times 2 is 24. So you can continue raising bases to exponents. You could have another parenthesis and continue on from there. It doesn't matter. You can go infinitely long. Just do not add them. Because the answer choices on the ACT, it will have x to the 15, but it will also have x to the 8 to make you doubt yourself. So you're like, oh, I don't remember if I add or subtract. They'll purposefully do it because they want to catch your mistakes because they don't want colleges to give you free money. What about power to a product? What should I do? What would I divide by? Yes, distribute the exponents of everything. So right here, a goes to x and a will go to y. So this becomes x to the a, y to the a. Distribute to everything. All right, what about the first example? 9x squared. So I'm going to distribute the 2, distribute the 2. So this is 3 squared x squared, and I'm going to simplify to 9x squared. Now, you can also combine all the other rules that we have learned. So in this next one, we're combining power to a power as well as the power to a product rule. So what happens on the second example? Yes, x to the 6th, y to the 4th. So what happens I'm going to write it out piece by piece so it looks like this. So what happens is you got to distribute the 2, and then you have to also multiply the exponents together because now I have a power raised to a power. So 3 times 2 is 6, so x to the 6th, y to the 4th. Be careful, a wrong answer that the ACT could give you is x to the 5 because they would add the 3 and 2. So they can put x to the 5, y to the 4, and put doubt in your head. Just be careful. All right, what about the last one? 9 plus x squared. Is that right? No. No. Oh, I know, it's so sad. I tricked you because that's not right. You can't do that. The reason I put that in there is because you do it all the time. Like all the time.
Oh, you do the 3 plus x, 3 plus x.
Yes. The plus sign, remember when you were factoring? You don't have to erase it. I'm going to just cross it out. I did it on purpose. So you have to distribute. If you have a plus or minus, this is wrong. Do not distribute the squared. You do it all the time. And it's okay that you do it. We're just going to learn from that mistake. It happens a lot. The reason it's incorrect is because you miss the middle term with the x value. You miss the 6x when you're distributing. So be careful, especially on answer choices where 9 plus x squared will be first, and it will be wrong. This is called the power to a product rule, which means it only works when we multiply. We can only distribute the exponent if we're multiplying, because the name of the rule is power to a product. So this rule is only for multiplying. It's a mistake that you make all the time. And it's okay to make it, but it's even better to learn from it. Do not distribute if it's plus or minus. You can't do that. You got to break it up and then do your multiplication. Okay? It's okay. It's just a mistake you make. All right. What about power to a fraction rule? What should we do here? Top and bottom. Good. So I'm going to put the a to the top and the a to the bottom. So this becomes x to the a over y to the a. And then from there, if you need to apply the division rule, do it. And so a lot of the rules, can be broken down to one step, but you can also do multiple steps in one. So for our first example, x over y squared becomes what?
X squared over y squared.
X squared over y squared. Good job. The 2 goes to the x and to the y. All right. What about the next one? X cubed. And then y to what power? Y to the 9. Remember, this is being raised and this is being raised. So the y cubed is being raised to the power of 3. 3 times 3 is 9. And for the last one?
32.
32.
X to the 5th.
Okay. Over.
Y to the 2nd.
Y to the 10. Good job. So everything. Yes. Do you want me to write that step? I can. So this becomes 2 raised to the 5th, x raised to the 5th over y squared quantity raised to the 5. So every single thing gets distributed. So for the top, this part up here, you're using the power to a product rule by distributing to everything. So the coefficient in front of the variable also gets the power. So an answer choice would have just 2x to the 5 over y to the 10 because they want you to forget to distribute to all. Okay. All right, x to the 0. What is x to the 0? 1. Anything to the 0 power is 1. Anything to the 0 is 1. So what's our first example? 3. So in the first example, only the x is being raised to the 0, which means this becomes 3 times 1, which is 3. And what about the next one? 5. Good. Again, only x to the 0. X is the only thing being raised to the 0, giving us an answer of 5. So be mindful of where the exponent is located, as well as what's with the variable. So what about the last one? That one is 1, because the 5 is with the x, and the whole quantity is being raised to the 0. So the problem that most of you will encounter is that middle example where there's no parenthesis around the 5 and x. You'll just think, oh, they're side by side, so they both must be being raised to the 0. If there's no parentheses, that's not true. Okay. All right, got just a few more before we do some examples and a practice. You guys remember exponent rules a lot better than my 4th period. They didn't remember it. Do you guys remember learning these? Okay, good. They were like, I've never seen this in my life. I was like, okay, good. All right. That makes me feel a lot better because I was worried. All right, negative exponents. So x raised to the negative a, what should I do with that? Yeah, under 1. So this becomes 1 over x raised to the positive a. Anytime you move the negative exponent, it becomes positive. So it's negative because it's not happy where it is. It's angry. So you flip it and move it to where it's positive and happy, where it wants to be. All right, what about the next one? 1 over x to the negative a. X to the positive a. So if there's nothing left in the denominator of your fraction just goes away. So remember, you can't do any rules like the division rule or anything like that until everything is positive. You only want to work with positive, happy exponents. All right, first example, x to the negative 5 over y squared. That's okay. Yep, where would the x to the 5th go? So this x to the 5 is not happy where it is. Okay. It will become x to the 5, but you got to move it to where it becomes positive. So y squared is good. It's going to stay. X to the 5 wants to come to the party and be positive and happy. What's left up top? 1. Remember, anytime you're dealing with a fraction, you want to make sure to leave 1 in the numerator if it goes away. If there's nothing left, put a 1. The ACT would give you an answer choice of y squared x to the 5 in hopes that you would forget about the fraction. So they might give you an answer that looks like this. That's not right. So just be mindful of that. If you know what the mistakes are, you'll be less likely to make them. Okay, what about the next one?
2x to the 3rd.
Yeah, 2x to the 3rd. So this x to the negative 3 needs to be shifted up, leaving us with 2x to the 3rd. There's no more fraction because there's nothing left in the bottom. Everything has disappeared, so you don't have to write your answer over 1. You need to zoom in, Jonathan. Can you see? Can you see that? You can move. Samuel's not here if you want to shift. Okay. Okay, next one. We got x to the 3rd over x to the negative 2. X to the 5. Good job. If you don't see it offhand, that's okay. What I would recommend is first shifting x squared to the top, and then noticing right here that you can add your exponents because of the multiplication rule. So 3 plus 2 is 5. All right. The very last one is fractional exponents, and we talked a little bit about that when we were doing GEMMA. So x to the a over b. How do I write that? How do I write x to the a over b? Yes, I am going to flip them.
Reciprocal.
Kind of.
So like AX.
Kind of. I think you're mixing it with logs. So I'm going to have a root in here. What goes inside of the root? X. That's a good start. So the base goes inside. What happens with A and B? Only one of them is going to go outside. One of them is going to be the power of A.
B is going to go inside of the index, and A is going to go as the.
Yes. There we go.
Is index right?
Yes. Look at you using your math words. I'm so proud. That's what it is. It's just carrying the weight around just infuses knowledge into her brain. All right, so we got x to the 3 over 4. So what is this one going to look like? Fourth root, x to the 3rd. Good job. Okay. What about x to the 1/2? Square root of x. So if you're unsure, write it down. And then remember, this is referred to as a square root because the index is a square, a 2. Square root. That's why it's called a square root. So if the index is 2, you don't have to write it. All the others you do. Because it is understood if it is by itself, it is referred to as a square root. All right, so take about 5 or 6 minutes and try the bottom 4. Online guys, do you need me to scroll it up so you can see it, or do you have the notes pulled up? I'll just scroll it up for you. And then I can pull it up in just a minute. So take a minute, practice. Okay, so number 1. The correct answer for number 1 is A. It is not B. So let's talk about why the ACT chooses certain numbers, okay? A lot of you did this, 35C, and then I'll rewrite it right here. A lot of you did 35 to the C, and then you multiplied 5 times 7 and got 35, and then you added 2 and 2 and got 4, and then you picked B. They purposefully chose 5 and 7 because 5 times 7 is 35. They purposefully chose those numbers so you would think, oh, I multiply. They're exponents, I'm trying to use the multiplication rule. They purposefully do that. They're picking numbers that you easily recognize to multiply to 35. However, if you're doing that, you're just applying incorrect rules. So all you really have to do is say, okay, 35 to the C, and then you just square. 5 squared times 7 squared is 1225. You're just looking for which exponent when you raise that to 35. So 35 raised to what power gives you 1225. You don't square root anything, nothing. So you just start plugging in answer choices. So 35 squared does equal 1225. So it's A. They purposely chose 5 and 7 to trick you. So if they had 12 to what power, they might give you 3 squared times 4 squared in hopes that you would do the same mistake. So be very careful. The ACT is tricky, but you are smarter than that. All right, number 2, the correct answer is A. Number 2 is A. So some randomness that they give you right here where it says A cannot equal 0 and B cannot equal 0, that's just telling you that you will not have an undefined fraction. So that just means that the denominator won't be 0. You can honestly ignore this. You're not plugging those numbers in. It's just so you can't find some weird loophole in the problem and there be more than one answer. That's it. They're just covering their butts. Now we have to apply all the rules. So the 2 is being raised to all these powers. So this becomes 4 squared, A to the 4 squared, and B to the 3 squared. If you're having trouble applying the rules without writing them down, write them down. Then I'm going to go down here. I've got 2a squared. This b to the negative 2 is unhappy, so I need to shift it up here. B to the positive 2. Do not do anything until all of your exponents are positive. Now I can start applying my rules. 4 squared is 16. A to the 4 to the 2, 4 times 2 is 8. B to the 3 to the 2, 3 times 2 is 6. And then I have b squared all over 2a squared. Then I'm just going to apply my rules. So 16 divided by 2 is going to stay in the numerator of 8. So I'm going to pause, look at my answer choices, and see that I have answer choices that have 2's in them. Those aren't right, so just eliminate them. Cross them out as you go. Get in the habit of crossing out incorrect answers. All right, then I've got a to the 8 and a to the 2. The 8 is larger. 8 minus 2 is 6, so a to the 6. So I can eliminate c. And right there, now I have a 50-50 chance of getting it right. Then I notice I have b to the 6 times b squared, so I'm going to add, becoming b to the 8, which is option A. If you would have subtracted these two, noticing that I have one in the top and in the bottom, you might have picked option B because it's b to the 4. It's okay, you're going to be fine. All right, let's try the next one. This one might be a little bit harder to read, so I'll zoom in. There we go. All right, so I'll rewrite it just in case, or well, we can pretty much kind of see that. I'll use a smaller. Okay, so I have 16 over negative 4. You only move negative exponents, not negative coefficients. Negative 4 can stay in the bottom. So 16 divided by negative 4 is negative 4. The 16 is larger, so it moves to the top of the fraction. Then I have r cubed, r to the 1. R3 is larger, so 3 minus 1 is 2. So r squared needs to be in the top of the fraction. Looking at my answer choices, I see r squared in the bottom. That's wrong. I see just r to the power of 1. Incorrect. And I see r to the power of 4. Incorrect. So just by doing 2 steps, I now have a 50-50 shot of doing it right. You don't have to finish the problems if you can identify the answer. Don't waste your time. Eliminate your choices. All right, then I have the value of t. So I have a t to the 1 here and t cubed here. T is larger in the denominator, so 3 minus 1 is 2, allowing me to eliminate e, leaving me with option B. I didn't even finish the problem, and I already have the right answer. You don't have to finish it. So z to the 5, z to the 2, that would just leave z3 up top. But if you know the answer, just stop and answer the question. Okay, the very last one before we do some practice. You should get y squared over x squared z to the 4. So the first thing you have to do is move your negative stuff. This comes down and this comes down, leaving me y to the 5 up top, x squared x4, y3 z4. And then I'm just going to combine. I'm going to simplify here with my y. Y is larger up top, so 5 minus 3 is 2. I have my x's here. I'm going to add those exponents. 2 plus 4 is 6. And then z is left alone. Okay. Anything I can clarify, either in person or online? Okay, let's do some practice.